Welcome. We're going to take a look at a problem involving constructing our own confidence interval. So let's take a look. You work for a chain of taco restaurants and you'd like to estimate the population mean of the wait times in the drive-through for all customers. So all of the customers would be our population, but rather than accessing every single customer, instead, what we'll do is take a random sample of 40 of the chain's drive-through customers and record the wait time for them. Assume it is known that the population standard deviation of the wait times, so population standard deviation would be our lowercase sigma. Unfortunately, in this problem, they're not emphasizing symbols, but it's always good to have that discussion. And when you're doing problems yourself, I would be writing that information down. So we're assuming that sigma, population standard deviation for customers, is 2.79 minutes. And based on this data that we collect, we're going to construct a 99% confidence interval for the true population mean of wait times in the drive-through for all customers. So this is the process of what we call inferential statistics. We're going to take 40 customers and base our conclusion about the entire population of customers on the results from the 40. All right, so step one is you need to pick your 40 customers. So we'll take a sample and see what happens. So the computer is randomly going to pick 40 customers. So this is our n, lowercase n would be our sample size. So we're going to be entering some information here for this sample that we took. So our sample size is 40. So I'm going to go ahead and put the 40 there. And then the mean for the sample was 4.56. So the sample mean, that's called our point estimate. So the point estimate is the single number that is our best, basically educated guess at the mean for the whole population. So this would be X bar. So sample mean, X bar, is our best estimate for the mean wait time for all customers. All right, and then it asks me for population standard deviation. So that was our sigma, 2.79. And then the critical value for a 99% confidence interval, and we are working with z-scores, because the sigma value is known to us and we're estimating a mean. So notice here, it does give you the sample standard deviation, which we would use if we were not told the population standard deviation in the problem. So when we're given population standard deviation, it allows us to base our critical values on the z distribution. All right, so 99% confident, that critical value is 2.576. All right. And then rather than us having to go through computations to find this information, the computer is going to go ahead and do that for us. All right. So the standard error of the mean, the margin of error of the confidence interval, and then the actual interval itself. So there's the point estimate, 4.56. And then the margin of error would be sort of our wiggle room here, plus or minus. And that margin of error was calculated as 1.13. All right, we're ready to visually display our interval. So based on that sample, we're going to enter the lower and upper limits of this confidence interval for the mean wait time of all of the customers. Okay, so let me start with the lower limit. So 4.56 is the point estimate. I'm going to come to my calculator here, 4.56. And we would subtract the margin of error to find the lower limit. So we'll subtract 1.13, and that gives me a lower limit of 3.43. So in this spot, 3.43, and it adjusts for us. So there's the 3.43. And then to get the upper limit, we take the 4.56, the point estimate, and now we add the margin of error, 1.13. And that brings me up to 5.69. So 5.69. Now they don't write a sentence in this problem. You'll see that that's the end of this question. However, let me just summarize. Based on this sample, I'm 99% confident that the true mean wait time for all customers, so I believe that the population mean wait time for all customers is somewhere between 3.43 minutes and 5.69 minutes. I am 99% confident in that result. So it's possible that the actual value is outside of that interval, but I'm 99% confident that I have created an interval that contains the true mean.